Hello friends, this is a different type of a question in which a voltage pulse is applied across the circuit and we have to find out the voltage across the capacitor. So let's see how to solve this question and what should be the approach. First of all, let's find out the voltage across the capacitor at steady state if a constant voltage pulse was applied to the circuit. So let's assume a 6 volt DC source over here, 3 kilo ohm, 6 kilo ohm resistor, 2 kilo ohm resistor, and the capacitor will be open circuited since this is steady state condition. So now VC will be 6 upon 3k plus 6k, which is the current flowing, into 6k, which is the voltage, and it turns out to be 4 volts. Therefore VC of infinity is equal to 4 volt. Now let's find out the time constant of the circuit. For finding out time constant, we will short circuit the voltage source since the internal resistance of voltage source is zero, so it is short circuited. So we have to find out the equivalent resistance across the capacitor. So 3 and 6k in parallel, so RP will be 3k into 6k divided by 3k plus 6k, which turns out to be 2 kilo ohms. So R equivalent is equal to 2 kilo ohm plus 2 kilo ohm, which is 4 kilo ohms. So the time constant of the circuit is tau is equal to R equivalent into C, which is equal to 4 into 10 raised to 3 into 200 into 10 raised to minus 6, which turns out to be 0.8 seconds. So now the charging equation of the capacitor is Vc of t is equal to Vc of infinity into 1 minus e raised to minus t upon Rc, where Rc is the time constant, is equal to 4 into 1 minus e raised to minus t upon 0.8. So since the pulse is up to 1 second, so at t is equal to 1 second, Vc of t is equal to 4 into 1 minus e raised to minus 1 upon 0.8, which comes out to be 2.85 volts. Now let's draw the circuit for t greater than 1 second. So the voltage source will be short circuited again since the pulse exists only for 1 second. So this is 3k, this is 6k, 2k over here. This is our capacitor 200 microfarad, which is charged up to 2.85 volts. Since there is no source in the circuit, now the capacitor will act as a source, thus discharging through the circuit, and the direction of the current flow will be in the opposite direction. So at t is equal to 1.5 seconds, or you can say 0.5 seconds after the capacitor is charged to 2.85 volts, the capacitor will start to discharge through the resistors. So we know that the discharging equation of a capacitor is given by Vc of t is equal to V into e raised to minus t by Rc, where Rc is the time constant, and over here V is 2.85 volts into e raised to minus t upon 0.8, which is the time constant, at t is equal to 0.5 seconds. Therefore Vc of t will be equal to 2.85 into e raised to minus 0.5 divided by 0.8, which turns out to be 1.52 volts. So hence we can say that Vc of 1.5 seconds is equal to 1.52 volts.